Here's something worth thinking about as you settle in tonight. That quiet sky outside your window shouldn't be quiet at all, but it is. Our galaxy holds hundreds of billions of stars, and most of them are older than our Sunday. Nearly all of them have planets. Run the numbers any way you like, and someone should have reached us long ago, long before there were any people here to notice. The sky should be busy. It should be loud, and it's not. In 1950, a physicist named Enrico Fermi put down his fork in the middle of lunch and asked a question that science still can't answer. Where is everybody? We call it the Fermi paradox, and here's the thing nobody talks about. The question isn't the scary part. The potential answers are: scientists have spent 75 years on this, and there are 10 serious solutions, and tonight we'll walk through every single one. You'll find out why there's a discovery waiting on Mars that would be the worst news our species has ever gotten, why hiding turns out to be impossible for them and for us, and why the two answers left standing at the end might mean the universe is younger and sleepier than anyone guessed. Nobody on Earth knows which answer is true, but one of them is. That's the thought that keeps scientists up at night. If you enjoy journeys that completely reshape how you see the universe, do me a small favor and hit that subscribe button. It genuinely helps this channel grow and lets me keep making these deep dives for you. Also, tell me in the comments where in the world you're falling asleep tonight. For now, dim the lights and settle in. I'll keep watch. Now, somewhere past your window, out in all that quiet, the whole question is hanging in the dark, waiting for us. Let's begin. Start with the window, because everything tonight lives in the window. Sometime in the last hour, in your house or in a house you remember, there was a moment like this. The last lamp in the room is still on. The glass has gone black with evening, and your own reflection is floating out there in the garden, hanging among the first few stars. Switch the lamp off, and the trick reverses. The room disappears. The sky steps forward. The glass goes cool under your fingertips, and the stars come out of hiding, one depth at a time. And for a moment, the window isn't a wall of the house anymore. It's the front of the house, the part that faces everything else there is. Now, here's a picture we'll use all night. Pretend the sky out there is a valley. A wide, dark, quiet valley, and you're seeing it from one small house on one slope of it. Every star is a bonfire, burning somewhere out on the valley floor. That much is honestly true because that's what stars are. Fires that light themselves. Nobody needs to strike a match for a star. Gravity gathers the fuel. The weight of the pile sets it burning, and it burns for billions of years without a single hand tending it. A wilderness can do that. Lightning can do that, so the valley is full of bonfires. Hundreds of billions of them, and every one of them is natural. But a lamp in a window is a different kind of light. A lamp is made. Somebody shaped it, filled it, and set it on the sill on purpose. And a lamp in a window has meant the same thing in every century and every country there has ever been. Someone is home. That's the whole question of tonight, in one line. The valley holds hundreds of billions of bonfires. And in all our years of watching, from the first upturned face to the newest telescope in the coldest orbit, nobody has ever once seen a lamp. Two quick things before we walk down into the valley, so your shoulders can stand down early. First, nothing in this story can reach you. Every answer tonight is an idea held at the distance of a telescope. Even the coldest of them belongs to stretches of time so far from this bed that they've got no more claim on your night than the weather in another century. You're not inside any of this. You're looking at it from a warm room through glass. Second, nothing here is urgent. This question is older than your grandparents. It has never once hurried anyone, and it'll keep perfectly well until you wake. You're allowed to fall asleep in the middle of any answer you like, even the one that unsettles you most. The valley has waited billions of years. It can wait until breakfast. And here's a strange little fact about the deepest question in science. It has a birthday. It has a lunch table. And it has a punchline that nobody wrote down. So, that's where we start. In the desert, in summer, 3/4 of a century ago, at the exact moment the silence of the sky stopped being scenery and became a problem. It's 1950, in the high desert of New Mexico, in a laboratory town up on a green mesa, where some of the most famous physicists alive are spending their summer. 4 of them are walking to lunch under a hard blue sky. One of them is Enrico Fermi, and to understand the next 10 minutes, you only need to know one thing about him. He's the man who can put a number on anything. His colleagues treat it as a party trick and a superpower at once. Ask him how many piano tuners work in a big city, and with nothing but common sense and arithmetic, he'll walk to an answer that turns out to be nearly right. He doesn't carry a notebook for this. He does it on napkins, on envelopes, in his head, on the way to lunch. The 4 of them are laughing about flying saucers. The newspapers that summer are full of sightings. And one of the men brings up a cartoon from a magazine that spring. A drawing that blamed a small mystery in New York, public trash cans vanishing from the streets, on cheerful aliens hauling them away in a saucer. The joke does its rounds. The talk drifts to whether anything could really cross the space between stars. Then it moves on to ordinary things. They sit down, plates arrive, and the sky over the mesa goes on being enormous, and blue, and empty. And then, in the middle of the meal, out of a silence nobody had noticed him keeping, Fermi puts down his fork and asks, loudly enough for the whole table, "Where is everybody?" The table bursts out laughing. And that's the detail all 3 of the other men remembered decades later, when someone finally went around and collected their memories. Everybody laughed. And everybody knew instantly, without one word of explanation, exactly what he meant and exactly who everybody was. The conversation had moved on half an hour ago. His mind hadn't. Where had it been all that time? Down at the bottom of the question, doing what it always did. Putting numbers on it, and the numbers had come out wrong. He ran them out loud over the table. The ages of the stars. The count of worlds. The time it takes to travel. And he reached the conclusion that hasn't moved in 3/4 of a century. By any reasonable arithmetic, we should have been visited long ago and many times over. Nobody wrote his exact words down that day. The 3 witnesses each remembered the phrasing a little differently. And it doesn't matter. The question outlived the lunch. It outlived Fermi too, who died 4 years later. And it wears his name tonight. The Fermi paradox. There's one more detail worth keeping, because it tells you how young this whole story is. The first real search of another star began 6 years after Fermi died. The man who asked the deepest question of the age never heard 1 minute of the listening. Everything you're about to hear, every dish and printout and volunteer and visitor, happened inside a single human lifetime. And it's still happening now, tonight, while you settle. Now, a paradox sounds complicated, but it's really just an argument between 2 things you trust. And this one is the cleanest in all of science. On one side, the count, a galaxy so rich in worlds and so old in years that life out there seems close to certain. On the other side, the record. Not one footprint, not one broadcast, not one lamp in one window, ever. And here's the uncomfortable part. Both sides keep getting stronger. Every year the telescopes find more planets, which raises the count. And every year the searches come home quieter, which deepens the record. The scissors open wider and wider, and nothing falls out. Every solution you'll hear tonight works by breaking one of the 2 blades. Either something makes the count wrong, and the valley never filled, or something makes the record wrong, and the valley is full of light we can't see or aren't being shown. Hold that loosely. That's the shape of the whole night. And by the way, that lunch wasn't the first time humanity leaned at this window. The wondering is old. The century before Fermi had already fallen in love once. In the late 1800s, a wealthy American astronomer named Percival Lowell built an entire observatory in the high desert of Arizona, in air chosen for its stillness, mostly to study Mars. And looking through his telescope at that small, shivering red disk, he saw lines, dozens of them, then hundreds. Straight as rulers, crossing at dark junctions, he mapped them year after year. He published books that sold like novels. The lines, he argued, were canals, waterworks the size of continents, built by a dying civilization pumping meltwater down from its poles to irrigate a world turning to desert. Respectable dinner tables spent a generation discussing the engineers of Mars. Was anyone there? The whole age wanted to know, and it wanted it so badly that when the answer finally firmed up, it landed like a small heartbreak. The canals were an illusion, a trick. A straining eye plays at the very edge of seeing, joining faint smudges into confident lines. There were no waterworks. The maps, it turned out, were portraits of the mapmakers, of how hungry the human eye is, at the window, at night, for signs of a neighbour. The hunger didn't go anywhere. It just changed instruments. When radio arrived, its pioneers pointed it upward almost immediately. Tesla, around the turn of the century, caught rhythmic clicks in his equipment and announced sincerely that they might be Mars calling. Marconi later heard things too. And in the summer of 1924, when Mars swung closer to Earth than it had come in a century, the United States did something wonderfully hopeful. The government asked the country's radio stations to observe scheduled minutes of silence, hour after hour, for 2 days, so the nation's receivers could strain for any signal from Mars. The Army even put its chief codebreaker on standby, ready to translate whatever came. Picture that August night, honestly. A young, loud, brand new technology. All crackle and jazz and advertisements, agreeing to hush on schedule. The whole dial going quiet in the dark. Room after room of headphoned listeners, breathing softly. A codebreaker sharpening his pencils. An entire country giving the neighbours their turn to speak. Nothing came, but the quiet was the point, though nobody knew it then. It was the first rehearsal of the listening that fills the rest of tonight, and it was the first proof of how gladly, how instantly, people will go silent together on the chance that the silence might be answered. So the desert lunch didn't invent the longing. What it added was arithmetic, the cold, clean scissors of it, and arithmetic is what turned a romance into a science. Now let's feel the size of what Fermi weighed at that table, because the paradox only lands if the count really is that generous, and it's more generous than he ever knew. Start with the stars themselves. Our galaxy holds somewhere around 400 billion of them. A number like that slides straight off a sleepy mind, so try counting instead. 1 star per second. No pauses, no meals, no sleep. Count all night, and you'll have passed 30,000 by sunrise. Count for a year, and you're just past 30 million. Not even a rounding error yet. To finish the galaxy at 1 star, every second takes more than 10,000 years. That's longer than the whole story of writing. And when you finished, you'd have counted 1 galaxy. Out of hundreds of billions. That's the field of fires we're talking about. 1 valley, in a country of valleys, with no far border anyone has found. And for most of scientific history, there was a real escape hatch here, because nobody knew whether stars generally came with worlds. Maybe planets were the miracle. Maybe the sun's little family was a freak of luck. And all those billions of fires burned alone, with nowhere for anyone to stand. That hope, or that fear, survived until the autumn of 1995. Within the lifetime of most people watching this, 2 astronomers in Switzerland caught a star called 51 Pegasi wobbling. Something unseen was swinging it in circles. A world, half the weight of Jupiter, huddled so close to its star that its year lasted 4 days. It was the first planet ever found around another ordinary star, and it broke the dam. The wobble hunters found dozens more. Then a space telescope called Kepler spent years staring at one small patch of sky, a patch you could cover with your palm at arm's length, watching 150,000 stars for the tiny wink that means a world has crossed the face of its sun. It found winks everywhere. By the time the counting settled, the verdict was plain. Planets aren't the exception. On average, there are more planets than stars. The default fire comes with worlds around it, and they're not all strange furnaces hugging their stars. Sift the Kepler harvest for planets about Earth's size, sitting at the comfortable distance where water can lie open on the ground, and you get something like 1 in 5 sun-like stars. Give or take an argument, 1 in 5. Run that through the galaxy, and you get billions of possible gardens around suns like ours. And that's before you touch the smaller, redder stars, which are more common still and carry temperate worlds of their own. Here's the part that always lands strangely. The nearest star to the Sun, a small red one, has a planet at the comfortable distance. The universe didn't hide the maybes in some far corner of the map. It put one on our doorstep. Then add the deep time, because this is what turns a pleasant thought into a paradox. Earth is 4.5 billion years old. The galaxy is more than 13 billion. That gap isn't padding. It's other people's history, waiting to have happened. And there are sun-like stars in your own neighborhood that were already ancient when the sun first lit. Stars whose planets, if they carried life, could have watched it rise and ripen 1 billion years before there was an Earth at all, 1 billion years of head start. It took us about 300,000 years to go from the first campfires to radio. So, what does a neighborhood elder do with 1 billion? Walk that head start once. Slowly, so you can feel how deep it goes. Give a neighbor civilization a mere 1,000 years on us. And their everyday tools sit as far past your understanding as the glowing telephone by your bed sits past a Roman blacksmith. And a Roman blacksmith is still someone we could share bread and jokes with. Make it 10,000 years, and the gap swallows every institution we've ever built, every language now spoken, the memory of every city currently lit. Make it 1 million, 100 times deeper again, and the travelers themselves have changed. The way we're not the creatures we were 1 million years ago, when nobody's ancestors had managed a full sentence yet, and 1 billion is 1,000 of those. When the elder sun's worlds were 1 billion years into their story, the most ambitious thing alive on Earth was a worm in the dark of the sea floor, still working out fronts from backs. Whatever rises across a gap like that wouldn't stand to us as explorers stand to islanders. It would stand to us as we stand to the worm. The honest limit of tonight is that nothing built of nerves can guess such a mind's errands. But the arithmetic insists on one thing. The time was there. The valley has had room for 1 billion years of practice, somewhere, many times over. And still, at our window, no lamp. Now, here's the part of the setup that refuses to bend, the blade of the scissors nobody has ever broken. You don't need magic to fill a galaxy. You don't need faster-than-light travel. Take a ship physics is perfectly happy with, crawling along at 1% of the speed of light. That's far beyond our workshops today, but it breaks no rules. Point it at the next star over. It arrives in a few centuries. Its passengers, or its machines, settle in, spend 1,000 years building, and launch 2 more ships. Nobody hurries. Whole civilizations of patience are allowed between hops, and even at that drowsy pace, the honest calculations all land in the same place. The wave crosses the entire galaxy, every star, every shore, in somewhere between 5 and 50 million years. Call it 100 million to be generous to every doubter. The galaxy has had time for that journey more than 100 times over. One traveler, ever, in 13 billion years. And every valley in the galaxy has a footprint in it. That's why the silence is loud. It only takes one. An astronomer named Michael Hart put the sharp version of this on paper in the 1970s. And it unsettled the field because it was so hard to wriggle out of. The fact to be explained, he said, is simple. They aren't here, and their absence from this one spot, our spot, quietly says something about everybody. Because for the galaxy to be both full and untraveled, every civilization that ever arose, without one exception, across 13 billion years, must have stayed home, or stopped, or turned back. Not most of them, all of them. And explanations that need everyone to behave the same way forever have a rot in the middle, because nothing alive has ever been that unanimous about anything. And you don't even need crews. A mathematician named John von Neumann proved, as an exercise on paper, that a machine can be designed to build working copies of itself from raw material. So send one probe to a nearby star system, let it mine an asteroid, assemble 2 daughters, and launch them onward. The mission pays for itself forever. From a single seed, riding on nothing but patience and sunlight and rock, the count of probes doubles and doubles, until, within a few million years, every star in the galaxy has been visited, watched, catalogued. One seed fills the valley. We could plausibly start building that seed within a few centuries of tonight. So the question isn't whether such a thing is possible. The question is why, in all the deep past, with all those elder suns, nobody else's seed is sitting quietly in our sky. Or whether one is, which is a thought for later in the night. So the count stands enormous. And the time stands enormous. To finish the setup, you need one more scene. The moment the question got its arithmetic, 11 years after Fermi's lunch, in 1961, a handful of scientists gathered at a radio observatory tucked into the green hills of West Virginia for the first meeting ever held on the search for life beyond Earth. The host was a young radio astronomer named Frank Drake, and the night before the meeting, needing an agenda, he wrote a single line of arithmetic on the blackboard. Take the rate at which the galaxy births suitable stars. Multiply by the fraction with planets, then by the number of livable worlds per system, then by the fraction where life actually starts, then by the fraction where it grows intelligent, then by the fraction that builds something detectable, and last, multiply by how long such a civilization stays detectable before it goes quiet, by choice or by ending. 7 knobs, 1 answer. The number of lamps burning in the valley right now. Here's the thing about that equation. It was never a calculator. It was a way of sorting ignorance into labeled drawers. And it worked beautifully, because it showed you exactly where knowledge stops. The first knobs, the astronomy knobs, we've since filled in with real measurements, and they came out friendly. Plenty of stars, planets nearly everywhere, temperate worlds by the billion. But what about the biology knobs and the history knobs? How often does life start? How often does it think? How long does it shine? Those aren't measurements. Those are confessions. The little gathering in the hills, which included a young Carl Sagan, ran their guesses and got a galaxy holding thousands of civilizations. Sober people, since running the same knobs with harder hearts, have gotten a galaxy holding roughly 1 to us. The same equation carries both answers without complaint. That's the honest state of the science tonight. The arithmetic of company is a fraction with a firm top and a bottomless bottom. Nobody knows. Nobody has ever known. So the drawers are labeled, and most of them are empty, which is where the answers come in. There are 10 of them worth your night. And it's worth saying plainly how they're going to behave, because the behaving is the interesting part. Each one is a serious proposal by serious people. Each one explains the silence completely on first hearing, and each one has a weak point that the field has spent decades pressing on. We're going to press on them too. You'll get each answer the way its author meant it, at full strength, so you can feel why it convinced people. And then we'll go looking for the crack. We'll walk them in order, from the most comfortable to the least. The early ones let you keep almost everything. A busy sky, an ordinary future, nobody at fault anywhere. Then the comforts start coming off, roughly 1 per answer. And here's the strange thing about this list. The thing that has held the field's attention for 75 years. The silence gets louder as you go, not quieter. By the 8th answer, we'll be somewhere the professionals are careful how they phrase things. 2 answers will still be standing after that. And what those 2 have in common is the most interesting fact in this whole story. I'd rather you arrive at it than take my word for it now. The first answer is the humblest on the list. The first solution says, nothing is missing. The lamps are out there, plenty of them, and we simply haven't looked yet. Not properly, not even nearly. And however strange that sounds after 60 years of listening, the numbers are entirely on its side. They're worth hearing in the dark, slowly, because they change how the silence feels more than almost anything else tonight. The listening began in 1960. In those same West Virginia hills, when Frank Drake, months before his famous blackboard, quietly borrowed the observatory's 85-foot dish for a project he named after a princess from a story, Ozma. For a couple of months of mornings, he pointed it at the 2 nearest sun-like stars, and he tuned it near the natural frequency of hydrogen. That's the note the universe hums in every direction. The one channel, a thoughtful stranger might guess that everyone else could hear. It was the first time in the history of our species that anyone deliberately raised a cupped ear to another star and waited. And on almost the first morning, the pen on the chart recorder went wild. A strong, regular, pulsing signal, exactly the kind of thing they were listening for. Arriving while the dish pointed at the second of the 2 stars. For a stretch of minutes that must have rearranged the insides of everyone in that room, it looked done. First try. Signal found. Then the pulses turned out to be coming from the sky in general, not the star in particular. And the answer assembled itself with a sigh. An aircraft, high up, almost certainly military, whispering its electronics down onto the quiet hills. The first lesson of the whole field arrived on its first morning. The sky is full of voices, and nearly all of them are ours. Hold that story, because it sets the honest scale of everything since. The searches after Ozma grew huge. Hundreds of projects sweeping thousands of stars, with receivers 1 billion times more sensitive. And they all inherited the same impossible chore, which is that the haystack isn't a haystack. It's a haystack of haystacks. A signal has a direction out of billions, and a distance and a frequency out of billions more. It has a timing, because the lamp might only sweep past you once a year or once a century. And it has a language of modulation you have to guess. Miss on any one of those, and you walk straight past a shouting sky and hear nothing. So searching for one deliberate whisper in that space, with our handful of dishes and our human budgets, isn't like searching a dark valley with a torch. It's like searching it through a keyhole in one color, during 1 minute, once. And if you had one night at a great dish, where would you even point the tuning? The searcher's answer is one of the quiet romances of science. In the radio sky, there's a stretch of unusual calm between 2 natural landmarks. On one side, the hum of hydrogen. On the other, the note of a molecular fragment called hydroxyl, Put a hydrogen atom and a hydroxyl together, and they make water. So between those two frequencies lies a hushed hollow in the spectrum, walled on either side by the two halves of water. Some early searcher named it the water hole, on the guess that thirsty travellers of every kind might gather there, the way animals gather at real water at dusk. It's only a guess dressed up as a place, but most of the great searches have lingered there anyway. Ears at the water hole, in the quiet hour. That's as close as radio astronomy comes to poetry, possibly as close as it comes to manners. The listening itself has a history with real tenderness in it. After Ozma, the idea caught properly. Through the 60s and 70s, some of its boldest friends were Soviet. Radio astronomers sweeping the sky from antennas out on the steppe, while a young theorist named Nikolai Kardashev sorted imaginable civilizations into 3 rungs by their appetite for energy. Those that gather the power of a planet, of a star, of a whole galaxy. Keep that ladder. We'll climb it again later tonight. In America, the field grew from borrowed hours into a plan. And in the autumn of 1992, the National Space Agency finally switched on its great official search. Decades in the designing. Built to sift more sky in its first minutes than everything before it combined. 1 year later, the funding was voted away. The official hunt ended almost before it had cleared its throat. But here's the part worth keeping. The astronomers didn't stop. They passed the hat, went private, and kept the receivers warm on donations. Which tells you something about the kind of people this silence recruits. And then the search did something no science had ever done. It moved into bedrooms. At the end of the 90s, a group in California released a screensaver. A small free program that would fetch a slice of raw telescope static over a household's slow internet connection and sift it for patterns while the computer sat idle. Millions of people installed it. At the peak, more than 5 million volunteers across the planet had lent their machines. For 2 decades, a real share of humanity's deepest listening was done in dens and dorm rooms and studies, at 2 and 3 in the morning, by beige computers humming through the static while their owners slept a few steps away. It found no signal. What it found instead was the size of the wish, offered the smallest possible way to help ask the biggest possible question. Whole neighborhoods of strangers, in every country with a phone line, quietly said yes. The Valley's one confirmed lamp, it turns out, leaves itself on at night, specifically to listen for the others. So how much of the ocean have we actually checked? A few years ago, 3 astronomers sat down and did the bookkeeping properly. They took every radio search for other minds ever run, all of them, from Ozma to the giant modern surveys, and added up how much of that many-dimensioned haystack has really been sifted against how much there is to sift. Then they translated the fraction into water, so a person could feel it. If the full search space were all the oceans of Earth, everything humanity has ever examined comes to about 1 large hot tub. That's the whole record. That's the silence we've been agonizing over since the lunch in the desert. We've drawn 1 warm bathtub from the sea, found no fish in it, and started composing theories about an empty ocean. And once, just once, the bathtub twitched. It was a hot August night in 1977. A big aluminum dish in a field in Ohio, an instrument its own builders fondly called the Big Ear, was doing what it did every night, sweeping the sky as the earth turned and printing what it heard as columns of numbers on fanfold paper. Days later, a volunteer astronomer named Jerry Eman sat at his kitchen table, working through the stack, line after line of the usual murmur, and then a column where the murmur stood up. A narrow signal, 30 times louder than the background, rising and falling over exactly 72 seconds. That's precisely the shape a source fixed among the stars would make as the turning Earth swept the telescope's gaze across it. It sat almost on top of the hydrogen frequency, the guessable channel. It was, in every measurable way, exactly what the whole field had been told to wait for. Eamon circled the column in red pen and wrote one word in the margin. And the word became the signal's name forever. Wow. The dish looked again the next night, and the next, and for a month of nights after that. Nothing. Bigger telescopes joined in over the years and decades. More than 100 follow-up attempts, some with instruments 1,000 times more sensitive than the Big Ear. The patch of sky it came from, out toward the crowded heart of the galaxy in the direction of Sagittarius, has been checked, and checked, and checked. It has never spoken again. Every ordinary explanation has been tried on, and none of them fits well. The frequency is a protected band that transmitters on Earth are banned from using. No satellite matched. A comet was blamed decades later, and the astronomers who knew the data best politely took the idea apart. So what's left is the purest small mystery in the whole story. 72 seconds. Once, from the direction of the galaxy's downtown, on the channel a stranger would choose. Maybe it was a rare natural flicker we don't understand yet. Maybe it was some human accident nobody ever traced. Or maybe it was somebody's lamp, sweeping past our window exactly once on a night we happened to be looking. Nobody knows. And short of it repeating, nobody ever will. The Big Ear itself is gone, taken down years ago. The field where it listened is a golf course now. Grass growing quietly over the spot where, one summer night, the ocean may have winked, now fold in the next piece, because it changes how the silence feels more than any other single fact tonight. While we listen for them, we ourselves are going quiet. Earth's loud age, it turns out, was short. For most of the 20th century, we sprayed our television and our radar into the sky sideways. Wastefully, gloriously, a bubble of chatter swelling outward at the speed of light. But leaked chatter thins fast with distance. Almost all of it fades below the universal hiss within a few light years, unless someone out there aims a very large dish at exactly the right moment and knows exactly what to look for. And the loudest of it is already behind us. Decade by decade, the broadcasts have moved into cables and fibers and tight little beams. The planet talks more than ever and leaks less and less. Run that forward and a strange picture forms. A technological world might be truly loud for only a century or so. One bright camera flash of radio. Then it goes efficient and quiet, still alive, still thriving, just no longer spilling. Now, light the valley with that rule. Every window flashes once, for a moment, somewhere in a night 100,000 centuries long. For two worlds to notice each other, their flashes have to be aimed right, and they have to overlap in time. The valley could have held 10,000 civilizations, and still, on any given evening, every window you check has either not flashed yet, or flashed ages ago, before anyone here had a window at all. We did, once, deliberately raise our own lamp, and the story of it is worth carrying to sleep. In 1974, the great dish at Arecibo, a bowl of mesh laid into a green hollow in the hills of Puerto Rico, turned its full power toward a tight cluster of a few 100,000 elderly stars and sang for 3 minutes. Inside the song, coded simply enough for a stranger to unpick, went a portrait of us, our counting numbers, the atoms we're built from, a stick figure of a human, a little sketch of the dish itself. Then it ended, and the message set out. The cluster it was aimed at sits 25,000 light years away. So the postcard has, tonight, covered roughly 1/500th of the journey. Everyone who composed it will be dust for hundreds of centuries before it arrives. The dish that sang it has already fallen. And none of that stops the message, which is out there right now. past every star you can see from your bed, still perfectly crisp, still faithfully carrying its little drawing of a person, the longest hello our species has ever said. Whatever else is true of us, we're a species that once spent 3 minutes introducing ourselves to strangers we could never meet, on the chance that somebody, someday, would be glad we had. That postcard also started a family argument that's still running, politely, in the journals. Should we transmit on purpose or only listen? There are really just two things a person can do at a window at night, and the field has both temperaments in it. One camp says speak, because a valley where everyone only listens stays silent forever by construction, and somebody generous has to go first. The other camp says a young household should learn the neighborhood before calling out into it, and the listening costs nothing. It's one of the few scientific arguments conducted almost entirely in the language of manners. It flares up gently every few years and settles again. And while it does, the actual ledger stays tiny either way. Across 70 years of the radio age, all of humanity's deliberate calls into the dark add up to a few scattered hours. In practice, without ever writing it down, our species has adopted the bedroom policy. Mostly listen. Speak rarely, and mean it when you do. So that's the first answer at full strength. And it's a good one. If it's right, nothing is wrong with the valley at all. The lamps are lit from end to end. The dark between them is only distance and timing, and the silence over your roof isn't an answer. It's a schedule. Of every idea tonight, this one asks the least and forgives the most. And in science, the boring explanation has a long habit of winning, now the crack, and it's not the one people expect. The weakness of the bathtub isn't that the bathtub is wrong. The measurement is honest, and the haystack really is that big. The weakness is what's been happening on the other side of the ledger while we drew it. 65 years ago, when the listening began, you could hold both halves of this problem in balance. We didn't know whether other stars even had planets, so a quiet sky was exactly what a quiet sky should look like. But every year since, the searching side has grown a little, and the should-be crowded side has grown enormously. We went from 0 known worlds beyond our own to nearly 6,000, to planets outnumbering stars, to temperate worlds by the billion. The count that makes the silence strange isn't the number that's been standing still. It's the number that's been climbing the whole time we've been listening. So the honest position is uncomfortable, not restful. Yes, we've sampled a bathtub from an ocean, and that alone would excuse the silence. But notice what's really happening. Our excuse is shrinking, while the thing it has to excuse keeps growing. The scissors open wider every year, and there's a harder version of the point, which the deep past supplies for free. This argument was never really about whether we can hear a faint voice from far away tonight. It was about why, in 13 billion years, with a galaxy crossable in 100 million, nobody ever arrived. No amount of poor listening explains an empty doorstep. The bathtub covers our ears. It doesn't cover our sky, which is why the field moves on to the second answer. And the second answer says the ears are the problem after all. Just not in the way we've been assuming. The second answer keeps the valley full and blames the receiver. Not its size, its design. Our dishes catch radio because radio is what we discovered first. The smoke signal of communication, loud, cheap, and leaky. And we've been holding it up to the sky like a man cupping his ear at a concert being played in a color he can't see. Think about it. A century in, we're already outgrowing radio ourselves. The old residents of the valley may write in channels physics allows and we've barely brushed. Flickers of laser light tighter than any beam we can aim. Patterns pressed into particles that pour through whole planets without touching them. Ripples in space itself, or mediums our textbooks won't name for another 1,000 years. Under this answer, the letter was never withheld. It was faithfully delivered. It's waiting at a post office we haven't found the door of. And nobody out there is ignoring us, any more than the radio stations of Earth were ignoring the year 1800. It's a good answer. And it has an ugly crack, and the crack has a shape you'll meet again several times before morning, so it's worth naming properly the first time. Call it the everybody problem. For this solution to explain the silence, it's not enough that most civilizations have moved past radio. Every single one has to have. Not one species, not one faction, not one outpost, not one enthusiast with a transmitter and a fondness for old methods, anywhere in the galaxy, across 13 billion years, can still be using the loud, cheap, easy channel that every technological species presumably passes through on its way to the better ones. And passing through is exactly what a phase means, which is where this one comes apart. Our galaxy holds stars at every stage of life at once. Newborns, steady middle-aged suns, swollen dying giants, all in the same sky, on the same night, because a machine this size is always doing everything at once. A valley full of civilizations should look the same. Some ancient and unreachable, some middling, and some standing right at our own clumsy stage, spilling radio in every direction the way we did for a century. We'd never need to overhear the elders. We'd only need to overhear somebody's adolescence. We've listened. The adolescents are missing too, so the second answer explains beautifully why we can't hear the wise. It doesn't explain why we can't hear the young, which brings us to the third answer. It agrees the letter exists, and it says something much stranger about why it never came. In 1973, a radio astronomer named John Ball, a sober man at a serious observatory, published a short paper suggesting, in effect, they know exactly where we are, and they're leaving us alone on purpose. Not out of caution, but out of policy. He called it the zoo hypothesis. The name has always been a little unfair to the idea, because what he described is less like a zoo and more like something we already do ourselves. We rope off nesting beaches. We fly drones around uncontacted peoples instead of landing. Barely out of our own trees, we've already invented the principle of letting young things develop unwatched and undisturbed. And we invented it the moment we were strong enough not to have to. So the zoo hypothesis just asks, why assume beings a million years older never had the same thought? Under this answer, the silence isn't distance and it isn't fear. It's manners. A rule kept by the old civilizations of the valley. And maybe the oldest rule they have. Young worlds get their childhood. No landings on the lawn, no voices from the sky, and no answers handed down before the questions have even finished forming, because a mind that's given every answer never becomes a mind. And notice how that would look from inside. From a small blue world still working on its questions, it would look exactly like this. A rich, busy valley, and one cottage at the edge of the woods where, by common agreement, the paths bend away, the lights stay low, and everyone passing keeps their voice down, the way adults keep their voices down in a hallway, at night, outside a room where a child is sleeping. And now the everybody problem comes back, wearing better clothes. For the preserve to work, the rule has to hold. Not mostly, entirely. It has to hold for every civilization in the valley, and every faction inside every civilization, and every crew on every ship, and every curious teenager of every species, for millions of years, without one slip loud enough for us to catch. Think about what that's asking. Our own single species, on one small planet, sharing one biology and one history, can't hold a common line on anything for a decade at a time. The third answer asks thousands of independently evolved minds who've never met, who share no ethics and no chain of command, to hold one line perfectly forever, and one defector ends it. One transmitter, one landing, one probe that wanders into the wrong system by accident, one lamp left burning in one window on one evening, Across billions of years, the odds of perfect compliance by absolutely everyone don't just get small, they go to nothing. So the third answer dies of unanimity, exactly like the second one did. And notice what's quietly happened to your night. 3 answers in, and each has failed the same way. Each needed every last resident of the valley to behave identically, forever. This is usually the point where the field stops asking what the neighbors are doing and starts asking a colder question instead. Not why is nobody speaking, whether anybody out there is remotely like us at all, because here's an assumption we've been carrying all night without noticing. Every search we've ever run assumes minds on our clock and our scale, creatures that live for decades. Think at the speed of nerves, build outward where telescopes can see, and chatter across the dark the way we chatter. But life kept none of those promises even on this one planet, where minds run on everything from 3 heartbeats a second to trees trading chemicals through fungus at the speed of seasons. Stretch that honesty across the valley, and the possibilities open like a night flower. The founders knew this, and there's a lovely proof of it in a story you already have. That first little meeting in the West Virginia hills, the one with the blackboard, gave itself a name, and the name wasn't the committee anything. They called themselves the Order of the Dolphin. One of the attendees had spent his career trying to talk with dolphins, and the assembled fathers of the search understood from the very first evening that their real subject wasn't radio. It was other minds. Whether 2 different kinds of mind can recognize each other at all, and the nearest test case wasn't up among the stars. It was out in our own grey seas, whistling in a language we've now been listening to for a century without cracking. We share a planet with the dolphins, a body plan, a mother's milk, an evolutionary yesterday, and their conversation is still a closed door to us. That's the humbling yardstick to carry into this family of answers. If the minds next door are still untranslated, the minds across the valley may be stranger than any search we know how to run. There could be slow minds out there, matter thinking at scales we'd read as geology. Imagine a being whose single thought takes a century. Its conversation with its neighbor is older than our species. It would experience the whole of human history, our pyramids and printing presses and radio telescopes and doubts, as one flicker between 2 words. We could aim every dish we own at it for 1,000 years, record 1 syllable, and file the syllable under natural rumble. And to a mind like that, our entire loud century isn't being ignored. It's simply too quick to be real. The way you've never once been introduced to a single turn of a hummingbird's wing. 2 clocks can share one valley and never strike together, and there may be a huge population of minds with no window at all. Look at our own solar system honestly. The most promising homes for life beyond Earth aren't planets with skies. They're oceans sealed under ice. Whole dark seas inside 2 small moons of the giant planets, kept liquid for billions of years by the kneading of tides, roofed over by kilometers of frozen ceiling. And if that arrangement is common, and by the count of icy moons it may be the commonest livable arrangement in the whole galaxy, then most of the valley's residents live indoors. Creatures could swim entire histories down there. They could build civilizations of touch and current and song in the warm dark. Grow wise. Grow old. And never once suspect there's such a thing as a sky, because their world doesn't have a window to stand at. No stars means no astronomy. No astronomy means no searching. And no searching means no loneliness of the kind this whole night is about, because the question can't even occur to them. The valley could be full of houses with no windows at all, lit inside, singing inside, and permanently, contentedly unaware of the street. No search of ours would ever hear them, and they'd never, not in a billion years, think to miss us. Or maybe the residents went inward instead of outward. Think about the direction of every technology you own. Smaller, denser, faster, cooler. Follow that arrow a few thousand years, and expansion starts to look like a phase. The toddlerhood of a civilization, because everything worth wanting, space, experience, whole worlds of it, is cheaper to build inward, in something the size of a teacup, than outward across light years of freezing dark. A mature civilization, under this answer, doesn't sprawl across its galaxy. It condenses. It folds its cities and its histories and its billions of minds into something small and deep and still, sitting quietly beside its star, radiating nothing but a little spare warmth, richer inside than the entire outside sky. The houses of the valley wouldn't be going dark because anyone died. They'd be going dark the way a house goes dark when the family gathers in one warm inner room and closes the door on the winter. But that spare warmth gives us something to check. And this is where one of the strangest telescope surveys ever run enters the story. Waste heat is the one bill nobody can dodge. Whatever a civilization does with energy, however clever it gets, the physics we met on another of our nights together still holds. Used energy leaves as warmth. Warmth glows in the infrared. And a civilization big enough to harvest a whole galaxy's starlight, the top rung of that old Soviet ladder, would make its galaxy glow strangely, dimmed in light, flushed with heat. So about a decade ago, astronomers combed through images of 100,000 galaxies, looking for exactly that fever. The infrared blush of galaxy-scale industry. They found interesting dust, busy star nurseries, and not one convincing empire. 100,000 galaxies, each with its hundreds of billions of windows, and nowhere in any of them the heat of anyone building big. So either nobody anywhere builds at that scale, which quietly retires a whole shelf of dark endings, or ambition itself isn't what we assumed, and the grown-ups of the universe are all small and deep and quiet on purpose. Having found the good room and closed the door, and once, for one strange season, the world thought the checking might have caught something. In 2015, volunteers combing through the Kepler telescope's public data, the same kind of at-home helpers who'd spent years sifting static, flagged one star as behaving wrongly. Here's what wrong means. A planet crossing its sun dims it by a fraction of a percent. A clean little wink on a tidy schedule. This star's light was collapsing by as much as a fifth, in ragged, irregular bites, on no schedule at all. Nothing else among 150,000 stars looked like it. The astronomer who led the study of it, Tabetha Boyajian, published the mystery honestly, and one line deep in the paper's list of possible explanations. The line noting the dimming was also consistent with enormous artificial structures passing in front of the star, escaped into the headlines and circled the world. For a while, respectable observatories and kitchen tables were turning over the same question. Had somebody, at last, been caught building? The public crowdfunded observing time out of their own pockets, and dishes turned toward that one point all over the world. The star was watched around the calendar for years, and the answer, when it came through color. Solid-built things block every color of light equally. Fine dust doesn't. It dims blue more than red. The dips ran blue heavy. It was dust. Veils and rivers of fine dust, its source still argued over, drifting between that sun and us. There was no construction site after all. But keep what the season revealed. At the first faintly plausible lamp in a century of watching, our species didn't look away and didn't lock its doors. Every instrument that could be spared leaned toward that one point of light, and strangers paid for telescope nights the way people chip in for a neighbor. Hoping. Whatever the valley turns out to hold, the cottage at the edge of it has made its own nature plain. We're the kind that runs to the window. There's even a wilder cousin of all these hidden hand ideas, worth exactly one breath. A storyteller once proposed that a sufficiently old and able civilization could, in principle, wrap a young world in a kind of planetarium. a curated sky, stars painted where stars should be, silence arranged where silence suits. The whole night a nursery ceiling built to let something small grow up, believing the woods are empty. Nobody can test it, which is why it stays a story. It earns its one breath for the shape of the thought alone. But hold the whole fourth family up to the light, and you'll find one crack running through all of it. Yes, some minds may be slow. Some may live in sealed oceans with no sky to wonder at. Some may fold themselves small and quiet. All of that is very likely true of somebody. It can't be true of everybody, and everybody is what the silence requires. You've now watched that same wall stop 3 answers in a row. This one also carries a problem the others don't. Because on this particular question, we didn't have to speculate. We checked. The infrared survey swept 100,000 galaxies for the heat of large works, and came home with not one convincing case. And that result cuts in both directions. It rules out empires, which is a comfort, but it also removes the comfortable middle where a busy valley might have been hiding behind our poor imagination. Because heat isn't a matter of imagination. Heat is a bill. It's paid in a currency our instruments can read no matter how strange the payer is. And nobody, in 100,000 galaxies, is paying it. Whatever is or isn't out there, it's not doing anything big. Which is why the field turns here to the possibility that's been waiting underneath the last 3 answers, that the reason nobody behaves like us is that there's nobody there to behave. So the 5th answer stops asking about behavior and starts asking about arithmetic. It's the most scientifically respectable idea of the night. It says the valley never filled. The bonfires are real. The worlds around them are real. And almost none of those worlds ever managed a resident, because the recipe for a living planet is far stranger than a warm orbit. This is the family called Rare Earth. And the way into it is to look around your own home, this ordinary blue place, and notice how much of what's keeping you alive tonight is luck that doesn't look like luck. Start with the moon, which is hanging somewhere over the valley right now, doing a job nobody thanks it for. It shouldn't really be there. A world our size has no business owning a moon that large. The best account of it is a catastrophe. When Earth was a newborn, a stray world the size of Mars struck it a glancing blow, and the splash of molten rubble, caught in orbit, gathered itself into the moon. A coin flip of cosmic traffic. Now here's what the coin bought. A planet's spin wants to wobble. Left alone, over millions of years, a world's axis can slowly tip and wander, dragging its climate zones with it, ice caps where the tropics were. No garden gets to keep its weather long enough to settle down. Our big moon's steady pull holds Earth's tilt nearly still, age after age. That's why the seasons keep their promises. Why winter is followed by spring at the same reliable angle it held 100 million years ago. That calm silver light on your curtains isn't decoration. It's a keel. And in the beginning the moon was closer, and it raised huge tides that flooded and drained the young shorelines twice a day, needing seawater and minerals through 1 billion tide pools, which may be where the first fragile chemistry of life was rocked. Rocked, like everything else that needs to grow, in something that swings. Then there's the biggest neighbor, Jupiter, out in the dark beyond Mars, 300 times our weight, patrolling the approaches. For years this was told as a simple story. The great goalkeeper whose gravity swats wandering comets away from the inner worlds. The honest, modern version is more interesting. The giant deflects some dangers and flings others inward, part shield, part slingshot, and the balance of its ledger is still argued over. But the larger truth holds. The architecture of a planetary system, where its giants sit, how gently they settled into their rounds, decides everything downstream, whether water gets delivered to the warm worlds early, whether the rain of stones tapers off in time for anything to keep what it builds. And we now know, from thousands of other systems that giant planets often migrate violently. They plow through their families. They scatter small worlds into their suns or out into the endless dark. Ours settled softly. Nobody fully knows why. The quiet street you live on was graded and calmed before you were born by residents who've never once been thanked. And zoom out one more ring, because even the sun's address in the galaxy is a quiet piece of luck. We live about 2/3 of the way out from the center, a dim, roomy suburb between two spiral arms, riding a nearly circular lane that keeps its distance from the crowded downtown. That distance isn't scenery. In toward the center, stars pack hundreds of times closer. Great, short-lived suns detonate near enough, and often enough, to scour whole neighborhoods. Passing stars rattle every system's shelf of comets loose as they brush by. Too far out, and the galaxy thins until the heavy atoms that build rocky worlds grow scarce. Some astronomers argue there's a comfortable ring between those fates, a temperate zone of the whole galaxy. How wide it runs is argued, but wherever its edges lie, we're inside them, orbiting in the calm, sparse, unhurried outskirts, where a planet can keep its comets on the shelf and its nights dark for 4 billion years at a stretch. Even our stretch of the valley, it turns out, is the sleepy end. And under you, right now, the ground itself is working a night shift. Almost no other world we know of works. Earth's crust is broken into slow plates that slide and dive and remake themselves. That motion is a thermostat. It buries carbon into the deep rock. Volcanoes breathe it back. And the loop has held this planet's temperature inside the narrow band where water stays liquid for about 4 billion years, through a sun that has grown a quarter brighter across that span. The house has central heating older than the continents. As far as anyone can tell, among all the rocky worlds we've ever examined, only this house clearly has it, and nobody knows why it started here and not next door. Deeper still, the planet's molten iron heart spins, and the spinning wraps the whole world in a magnetic tent that leans against the solar wind all night, every night. Mars is the cautionary tale. Its heart cooled early, its tent fell, and the wind of its star slowly peeled its air and its water away into space. That's how a world that once had lakes became a red desert. So two invisible kindnesses, the thermostat and the tent, are being performed beneath your bed as you listen to this. Neither one was guaranteed. But the strongest cards in the rare earth hand aren't places. They're events. Single moments in the history of this planet that, as far as the record shows, happened exactly once. And the once is the whole point. Life itself appeared quickly. We'll come back to that. It's what life did next that's strange. Nothing. For something like 2 billion years, the most interesting thing on Earth was a film of single cells quietly running the oceans. History was so still that geologists, with a candor you have to love, call the middle stretch of it the boring billion. And then, on some unmarked afternoon deep in that stillness, one cell engulfed another, a meal like 1 billion trillion meals before it. Except this meal survived. It stayed inside, and it kept working. The swallowed cell became a little engine, paying for its lodging in energy. Its landlord became the first of a new kind of cell, rich enough to grow large and complex and extravagant. You know the little engine's descendants, T, and zoom out one more ring, because even the sun's address in the galaxy is a quiet piece of luck. We live about 2/3 of the way out from the center, in a dim, roomy suburb between two spiral arms, riding a nearly circular lane that keeps its distance from the crowded downtown. That distance isn't scenery. In toward the center, stars pack hundreds of times closer. Great, short-lived suns detonate near enough and often enough to scour whole neighborhoods. Passing stars rattle every system's shelf of comets loose as they brush by. Too far out, and the galaxy thins until the heavy atoms that build rocky worlds grow scarce. Some astronomers argue there's a comfortable ring between those two fates, a temperate zone of the whole galaxy. How wide it runs is argued over, but wherever its edges lie, we're inside them, orbiting in the calm, sparse, unhurried outskirts, where a planet can keep its comets on the shelf and its nights dark for 4 billion years at a stretch. Even our stretch of the valley, it turns out, is the sleepy end, and under you, right now, the ground itself is working a night shift almost no other world we know of works. Earth's crust is broken into slow plates that slide and dive and remake themselves. And that motion is a thermostat. It buries carbon into the deep rock. Volcanoes breathe it back. And the loop has held this planet's temperature inside the narrow band, where water stays liquid for about 4 billion years, through a sun that's grown a quarter brighter across that span. The house has central heating older than the continents. As far as anyone can tell, among all the rocky worlds we've ever examined, only this house clearly has it, and nobody knows why it started here and not next door. Deeper still, the planet's molten iron heart spins, and the spinning wraps the whole world in a magnetic tent that leans against the solar wind all night, every night. Mars is the cautionary tale. Its heart cooled early, its tent fell, and the wind of its star slowly peeled its air and its water away into space. That's how a world that once had lakes became a red desert. Two invisible kindnesses, the thermostat and the tent, are being performed beneath your bed as you listen to this. Neither one was guaranteed, but the strongest cards in the rare Earth hand aren't places. They're events. Single moments in the history of this planet that, as far as the record shows, happened exactly once. And the once is the whole point. Life itself appeared quickly, and we'll come back to that. What life did next is the strange part. Nothing. For something like 2 billion years, the most interesting thing on Earth was a film of single cells, quietly running the oceans. History was so still that geologists, with a candor you have to love, call the middle stretch of it the boring billion. And then, on some unmarked afternoon deep in that stillness, one cell engulfed another. A meal like a billion trillion meals before it, except this meal survived. It stayed inside, and it kept working. The swallowed cell became a little engine, paying for its lodging in energy, and its landlord became the first of a new kind of cell, rich enough to grow large, complex, extravagant. You know the little engine's descendants tonight as mitochondria. They're in nearly every cell of your body, burning your dinner into warmth as you lie there, which means you're, among other things, the rent paid on a 2 billion-year-old tenancy. And by every sign in the deep record, that merger happened once. Once, in 4 billion years of oceans stuffed with candidate cells bumping in the dark. Every animal, every plant, every mushroom, every mind, every person you've ever loved descends from that single lucky lunch. Once you notice one of those, you start seeing them everywhere in the family album. The kind of photosynthesis that fills a sky with oxygen. Invented once. The leap from single cells to bodies, to creatures with fronts and backs and mouths and plans. Successfully attempted once, in the sprint of invention 500 million years ago, that scientists call the Cambrian explosion after 3 billion years of patience. Language, the trick of folding a whole world into sounds so another mind can unfold it, once, as far as anyone can tell. So the ladder from chemistry to conversation turns out to have several rungs that look less like steps and more like lottery wins. And here's the cold arithmetic of that. If even 3 or 4 of those rungs are genuine 1 in a million chances, then multiply them out. And the expected number of talking civilizations in a galaxy of billions of gardens quietly drops below 1. No forest, no filter, no drama, just a valley of green and living worlds, oceans full of microbes, shorelines full of weed and shell, and nothing, anywhere, that ever needed a lamp. There's one more version of rare, and it may be the most poignant one. Perhaps life starts easily and simply fails to keep house. A young planet is an unstable home. Its star brightens. Its atmosphere wobbles between furnace and freezer. And some scientists argue that the only worlds that stay livable are the ones where life itself seizes the controls fast, spreads planet-wide, starts regulating the thermostat before the house tips past saving. Look at our own street for the evidence. 3 worlds sat in or near the comfortable zone when the sun was young. Venus may well have had oceans. Mars certainly had lakes and rivers, and we photographed the dry riverbeds. 2 gardens failed. One boiled slowly under a runaway sky and hides now behind permanent clouds. One dried and froze into red dust, and one, ours, happened to green itself quickly enough to take over its own weather. By this reading, the valley is scattered with houses that stood beautiful for one bright season, held life briefly, and lost it before anything in them ever looked up. Not a wall of fire. Just gardens, going quiet, the way gardens do when no gardener comes. And yet the rare earth family has one soft spot. And honesty at bedtime means showing it to you. Life here began fast. The oceans formed, and almost as soon as the rocks can show us anything at all, within the first few 100 million years, they show chemistry with the fingerprints of living metabolism. So on the only world you and I can check, the supposedly impossible first step looks almost eager. What do you do with a clue like that? That either means starting life is easy, which unrares the whole argument, or it means we're the one lottery winner examining our own ticket. And winners always find their own history written in what look like miracles, because only where every step succeeded is anyone home to read the record. 1 data point, 2 readings, and no way yet to choose. Nobody knows. It's one of the few questions on Earth that a single robot arm, scraping one lucky rock on Mars, could settle within your lifetime. So hold the rare Earth answer up to the window, because it changes the room you're lying in more than any answer yet. If this family is right, the silence isn't absence. It's scarcity of the most literal kind, and everything ordinary around you is galactically exotic. The rain that taps the glass, delivered by a thermostat almost no world owns. The steady seasons, held by a moon almost no world gets. The oxygen riding into your lungs right now, exhaled by an invention that happened once, and kept burning by one lucky lunch 2 billion years old. You've spent your whole life inside the rarest object anyone has ever pointed a telescope at. And then you do the arithmetic, and the arithmetic won't cooperate. That's the crack in the 5th answer. And it's a plain one. Rare isn't the same as absent. Suppose every hurdle on that long list is real, and the whole chain of luck is 1 billion times less likely than we'd ever have guessed. 1 billion is a serious discount. It's also nothing at all against the numbers we started this night with. 400 billion stars in this galaxy alone. So a 1 in a billion chance still leaves hundreds of living worlds in the Milky Way. And every one of them has had billions of years to make something of itself. Widen the frame to the hundreds of billions of other galaxies. And rare Earth stops explaining anything at all, because a fantastically rare event, run on a machine this large, simply happens and keeps happening. To empty the valley, you can't make life merely rare. You have to make it very nearly impossible. And the ease with which it started here is the one piece of evidence we hold on that question, and it points the other way. So the 5th answer does real work. It lowers the count. It never reaches 0, and the silence stays louder than the explanation. Which brings us to the famous one. If tonight has a celebrity, this is it. The answer people arrive already knowing. The one with the beautiful, frightening name. The dark forest. A Chinese novelist, Liu Cixin, gave the old idea its name and its fable, and the fable deserves telling properly in the low voice it asks for. So imagine the galaxy as a forest at night. Through the trees, here and there, other travelers are moving, and every traveler carries the same two facts. Anyone you meet might be dangerous, and there's no way to size a stranger up from far away, because by the time their nature is clear, they're close. Under those rules, the reasoning runs, the wise traveler does one thing: go quiet. Hood your lamp, make no sound, and if you glimpse another light through the trees, the coldest version of the logic says you don't call out to it. So the forest fills with travelers, all silent, all careful. And the silence of the night sky stops meaning nobody is there, and starts meaning everybody is, standing very still among the trees. It explains the crowded count and the empty record in a single stroke. It clicks shut like a well-made box, and that click is why the idea conquered the world. But the box has a false bottom, and you find it by asking one homely question: can anybody actually hide in this forest? Because the fable only works if going quiet keeps you secret. And for a real planet, it doesn't. You're breathing the reason as you lie there. For something like 2 billion years, since long before anything here had a spine, Earth's air has been loaded with free oxygen, and free oxygen is a screaming anomaly. It's so reactive that it should scrub itself out of any atmosphere within ages, unless something alive keeps pumping it back. So any patient astronomer within tens of light years, with instruments only modestly better than our own, could have read the signature of our air as our world crossed the face of the sun and concluded, correctly, someone lives there, before the dinosaurs, before the trees, before anything on Earth had ever made a sound. And we're learning to run that exact test on other worlds right now, tonight, with our first great cold telescope parked out beyond the moon, reading starlight strained through the atmospheres of small planets. Hiding was never on the menu for a living world. Our address has been published for 2 billion years, and the knock has never come. Every quiet morning, in 2 billion years of mornings, is the forest testifying against its own fable. And once the hiding fails, the rest of the box comes apart gently in your hands. Think about what silence would actually cost you if you kept it. No great works, no bright cities, no singing into the dark. For as long as your species lasts, it's a sentence with no end and no parole, self-imposed, on the strength of a fear nobody can check. The cold arithmetic of striking first turns out, when you actually do it, to be expensive and self-defeating, because reaching across light years takes centuries of exposed effort, and anyone capable of it is capable of being seen doing it. And the whole fable needs every mind in the galaxy, whatever its chemistry, whatever its childhood, to run the same cold calculation and reach the same conclusion forever, without one defector, one optimist, one reckless singer. In 13 billion years, nothing alive has ever been that unanimous, and we ourselves, the only sample in the jar, learned the risk and sang anyway. 3 minutes of it, straight at a cluster of a few 100,000 stars, and the singing wasn't even the boldest thing we did. In the late 1970s, we launched 2 small ships on a grand tour of the outer planets. And because their paths would carry them out of the solar system forever, somebody thought to pack for the distance. Bolted to each one is a gold-plated record, a real playable record, carrying greetings in dozens of languages, the sound of surf and rain and a heartbeat, more than an hour of the Earth's music, and the recorded hum of one young woman's brain as she thought about being in love. And engraved on the cover, for any stranger who ever finds it, is a map, the location of our sun, drawn in the bearings of 14 lighthouse stars. A return address, written in the most permanent handwriting we know. Both ships are still out there tonight, the farthest things human hands have ever made, decades past the last planet. They'll drift among the stars for 1 billion years or more, outlasting the pyramids, outlasting the continents in their current shapes, quite possibly outlasting us. So whatever the far future ever learns of Earth, the first physical fact of us anyone could hold is a letter of introduction with our address on the envelope. A species that truly believed in the forest would never have dared. We dared. Twice. So where did the forest really come from? Not from the sky, which has never once behaved like it. It came from here. It's our own history. The ships and the shorelines, the arrivals that went badly on this world, walked outward and painted across the stars. The dark forest is a mirror, and what's standing in it isn't the galaxy. It's us, at our worst remembered moment, multiplied by every light in the sky. And a fear learned at home, however honestly learned, isn't a law of nature. The valley isn't obliged to be our history with more stars in it. So the famous answer fails too. And it fails in the most unwelcome way available. Because look at what its failure leaves lying on the floor. For all its coldness, the dark forest was an answer that let the valley be full. It said the neighbors are here, hooded, breathing quietly, alive. Take away its hiding place, and you don't get a friendlier sky. You get the same empty one, with one more excuse spent. If nobody can hide, and our own address has been legible for 2 billion years, then shyness was never the reason nobody came. 6 answers down, and every comfort we've picked up has come apart in our hands. The ears, the channel, the manners, the strangeness, the rarity, and now the fear, which leaves the field one move. It made that move in 1998, and it reorganized the entire question. Stop asking what the neighbors are doing. Start asking what happens to everybody. All those hard steps, the lucky moon, the lucky lunch, the once-only inventions, were eventually gathered under one roof by a single idea, and the idea has a name that sounds ominous, and an inside that mostly isn't. In the middle 1990s, an economist named Robin Hanson read the silence the way an accountant reads a ledger that won't balance, and wrote down the plainest possible statement of the problem. Somewhere along the road that runs from dead chemistry to a civilization lighting lamps across a galaxy, there must be at least one step so improbable that almost nothing, anywhere, ever gets past it. There has to be, because if every step were easy, the sky would be busy, and the sky isn't busy. He called that step the Great Filter. The name is the honest kind of scary, but notice what the filter actually is. Not a thing, not a force, nothing that does anything. It's a missing rung, located nowhere yet, known only by its shadow, and the whole question of tonight folds down to one strangely simple puzzle. Where along the road is the rung missing? Behind us or ahead of us? Behind us is the friendly address, and everything in the rare Earth family is a candidate for it. Maybe the filter is the first spark of life on sterile rock. Maybe it's the lucky lunch that built complex cells with its 2 billion year weight. Maybe it's the leap to language. It only takes one of them to be nearly impossible, and the whole silence is explained. And look at what that version means, because it's worth saying slowly. If the filter is behind us, then the hard part of the universe's whole project is finished. Here, in you, the empty valley stops being a warning and becomes a summit view. It's like climbing all your life inside a fog, complaining about the loneliness of the trail, and then reaching a high meadow at night, looking out, seeing no other lamps on any peak in any direction, and understanding, all at once, that the mountain was nearly unclimbable, and that everything you thought was ordinary about your childhood was the climb. So that's the filter behind us, and it's genuinely the good address. The silence as your certificate. Every empty window in the valley, a measure of how far your particular dust has already travelled. Keep hold of it, because we've arrived at the eighth answer. And the eighth answer is the whole reason this question has the reputation it has. The ledger allows the other address. The missing rung may be ahead of us. Here's the shape of it, said as plainly as it deserves. Worlds reach lamps routinely. The valley lights up over and over, exactly as the arithmetic insists it should. And then, somewhere within a few centuries of learning to shout, every single one of them goes quiet. Not most of them. All of them. So where does that put the missing rung? Somewhere after radio and before the stars. And that's a stretch of road we happen to be standing on tonight. That's the sentence people mean when they call this question frightening. I'm not going to soften it here, because you'll hold it better having actually seen it. And here's the part that gives it teeth, which is the thing I promised you back at the window. Every discovery of the last 30 years has pushed the rung forward toward us. Think about how a missing rung has to be located. It sits at whichever step in the long road is nearly impossible. So every time we prove a step is easy, that step comes off the list of candidates, and the search moves up the ladder. When nobody knew whether other stars had planets, planets could have been the impossible step. Then we found thousands, and that drawer closed. When nobody knew whether temperate worlds were common, they could have been the step. Then the counting came in at billions, and that drawer closed. Life beginning on this world, almost the instant the rocks had cooled, is another closed drawer. Every one of those closures is a genuine triumph of science, and every one of them narrows the road. And the part of the road still unaccounted for, the part nobody has ever shown to be easy, is the part in front of us, which is where the loop I opened at the window finally closes. On a rusty world you can see from your own garden on a clear night, an ordinary orange point in the east that people have wished on for as long as there have been people. If we ever scrape a Martian rock and find life inside it, life that began there on its own, separately from ours, then in a single afternoon we learn that starting life isn't the hard step. It happened twice on one street. The origin of life comes off the candidate list. The last of the early drawers closes, and the missing rung has almost nowhere left to sit except ahead of us. That's why a philosopher in Oxford once wrote the strangest sentence in this entire literature, that finding life on Mars would be the worst news our species has ever received. Not because anything on Mars could harm anyone, because of what its existence would say about the road we're walking. And there are, tonight, sealed tubes of Martian rock sitting in the dust of an ancient river delta, waiting for a ride home. Some of the people who filled them understand perfectly well that they may have packed the answer to this, and that the answer they'd prefer is nothing at all. So take the eighth answer at its full weight, because you walked all the way down here to earn it. It says nobody hid, nobody moved to a better channel, nobody was shy, nobody was rare, nobody was unrecognizable. It says the valley filled with lamps, over and over, for 13 billion years. And every one of them went out at roughly the point in the evening where we're standing now. It says the reason the sky is quiet is that quiet is simply what happens. And it says that our being able to ask the question at all isn't evidence that we're special, only that we're recent. That's the coldest thing anybody has ever said about the night. And now that you're holding it whole and undressed, I can show you what it's actually made of, because I've been keeping one thing back all night. It isn't a measurement. That's the whole of it, and it matters more than it sounds. Every other claim tonight rested on something somebody counted. Stars, worlds, decibels, degrees. The heat of 100,000 galaxies. The eighth answer rests on nothing but the silence itself. And the silence, as we've spent this entire night establishing, has at least 10 possible parents. The filter ahead is what you get when you take the one observation we have and assume the least generous of its meanings. There are two reasons that assumption is weaker than its reputation, and behind them one plain fact that undoes it. Not one of the three is wishful. All of them are things you can check from where you're lying. The first is sitting in that sealed tube on the red plain. The worst news reading assumes the road from chemistry to civilization has the same steps, in the same order, at the same difficulty, on every world in the universe. And that's an assumption nobody has tested and nobody currently can. Turn the tube over, and it reads the opposite way. Microbes on Mars would be the greatest discovery in the history of biology. Proof that the universe writes life wherever the conditions allow it. Both readings are inside that tube tonight, and neither can be weighed until somebody opens it. A conclusion that can be reversed by an unopened sample isn't a finding yet. It's a guess wearing a finding's clothes. The second reason is that quiet isn't one thing. Notice how much work that one word has been asked to do all night. A world that ends goes quiet, yes, but so does a world that grows up. We ourselves, one single civilization, went from silent to deafening to hushed in 100 years, not by dying, but by switching to fiber and beams. We got quieter while becoming more capable, not less. A world that turns its attention inward goes quiet. A world that moves its business to channels we haven't learned goes quiet. A world that simply stops wasting energy goes quiet. The way a house at midnight is quieter than a house at noon, and means nothing sad by it. So for the silence of the whole valley to prove an ending, every single world, without exception, would have to have taken the one dark road. When the record right in front of us, shows the quiet roads outnumber it and are easier to walk. Ended is one member of the family called quiet, and it's the strangest one to assume is universal. There's even a mathematics of simply petering out. An engineer named Geoffrey Landis once modeled the settling of a galaxy, the way physicists model water soaking through coffee grounds. Each settled world decides for itself, by its own lights and budgets, whether to send out the next ships. Settling is always costly, and some worlds always decline. Run that game 1,000 times, and a remarkable pattern falls out. The wave of settlement doesn't flood evenly, like dye in water. It creeps and branches and pools, and wherever enough neighboring worlds happen to say no, the front stalls, permanently, leaving holes. Great volumes of untouched stars, locked inside the settled regions like bubbles in bread. No fear required, no policy, no wall, only ordinary reluctance, compounding, and the obvious ending of that thought is close to home. We may simply live in one of the holes, a quiet pocket, passed around rather than through, the way every mountain country has valleys the railway never reached. Not because the surveyors feared them, because the line happened to bend elsewhere a century ago, and nothing since has ever needed to change it. Nobody chose our silence. It pooled. And the valley shows no wreckage, which matters more than it first sounds. Think about what you'd expect to see. If civilizations regularly rose to great size and then fell, the galaxy should hold ruins, half-built works gone cold, engineered things drifting unexplained, the warmth of abandoned industry leaking into the infrared for millions of years, because big structures outlive their makers by geological ages. Astronomers have genuinely checked. That survey of 100,000 galaxies found not one convincing case. However you read that, it isn't the signature of a valley that keeps building and burning. The dark out there reads unbuilt, not burnt. No smoke hangs over any hillside. And a universe with no ruins in it is a universe where either nobody builds big or nobody falls hard. Both of those, whatever else they mean, are calmer than the reputation this stretch of the night carries. Notice too where all of this lands in that old blackboard line of arithmetic. Of Drake's 7 knobs, the one the whole answer swings on hardest is the last one. The lifetime knob, the number of years a lamp, once lit, stays lit. If technological worlds typically shine for a few centuries, then the valley at any given hour is empty. And nobody ever overlaps with anybody. However many lamps, history lights. If they typically last 1,000,000 years, the valley hums. Every other knob is nature's business. But the last knob is character. And the people who ran the first searches understood, and said out loud, that in asking whether anyone else lasts, humanity was really asking whether lasting can be done at all. That's why so many of the founding searchers spent their public lives pleading for patience between nations. The search was never idle curiosity. Pointing a dish at the sky was a way of voting that the last knob turns out to be a large number. Theirs and ours alike, and every quiet night of listening since has carried that same vote. And behind both of them sits the plain fact, the one to carry down into sleep because it's the simplest and the one most often forgotten. Not one civilization has ever been observed failing. Not one, anywhere, ever. The eighth answer describes the fate of everybody, and it was assembled from a sample of nobody. From 0 examined cases. By taking an empty sky and choosing its bleakest available reading, that isn't a measurement. It's fear doing arithmetic. And fear is a poor arithmetician. And it has never once had access to the data it claims to be summarizing. Whether any wall stands centuries ahead of any species is a question for daylight. For treaties and institutions and careful engineers, and it's being worked on in daylight by people who chose that work. Not one atom of it is decided or helped between now and your morning. And then there are the last two answers. They're the reason I asked you at the window to wait. They've been sitting at the bottom of the list all night. And neither of them requires anything, anywhere, to have gone wrong. And now the tenderest one. Of every solution ever published in a serious journal, the one that belongs most to a night like this arrived in 2016 from 3 physicists working through the far future of thinking itself. It begins with a fact from the very bottom of physics. Thought has a price, and the price depends on temperature. Every computation, every remembering and reckoning, in a brain or a chip or whatever the elders of the valley think with, must eventually pay a small toll of energy. And the toll is smaller the colder the universe around you is. Arithmetic is cheaper in the cold, not as a metaphor. As measured law, and the universe, still warm with the leftover glow of its beginning, is cooling. Slowly, steadily, reliably, forever. So the 3 physicists ran the ledger an old civilization would run. Take everything you have, every star you could ever harvest, every jewel you'll ever own, and ask the only question that matters to a mind that intends to live forever. When should we spend it? Spend it now, in a warm young universe, and the toll on every thought is high, and your hoard buys so much thinking and no more. Or wait. Put everything in order. Set the automatic systems watching and sleep, while the universe cools around your stillness, age upon age. Every degree it drops makes every remaining jewel buy more thought, and wait long enough, into the deep, cold trillions of years from now, and the same hoard buys 1,000,000,000,000,000,000,000,000,000 trillion times more. Not a little more. Not double, a 1 with 30 zeros more. So if minds can pause without loss, the mathematics stands up and says something almost nobody expected it to say. The wisest thing an advanced civilization can do with the universe is sleep until it's ready. Physicists have argued about the bookkeeping ever since, as physicists should, and it may yet fall apart in daylight. But lie still with the picture it paints, because nothing else in tonight's whole catalogue fits the hour like this. The valley isn't empty. The valley went to bed. The oldest minds in creation, having seen everything the warm morning of the universe had to show them, looked at the long night ahead and understood that it wasn't a diminishment, it was the treasure. The deep cold future is where all the real thinking lives. So they banked their stars the way you bank a stove, set their alarms for a morning trillions of years away, and lay down. No fear, no fall. The silence over your roof, by this answer, is the silence of the biggest bedroom there has ever been. And the reason nobody answers our little calls is the same reason nobody answers a doorbell at 3 a.m. The household is asleep. The household is wise, and everything worth staying up for will keep. Of all the shapes the silence might turn out to have, no other one rhymes with your evening like this. You, and possibly everything old and knowing in the universe, agreeing on the same strategy tonight. And what would minds like that dream about? For 1 trillion quiet years, nobody knows. Nobody knows whether they'd dream at all, or what the patient caretaker machines hum to themselves while the household sleeps, checking the locks once an age, dusting the constellations. It's the one question in tonight's whole catalogue that somebody, somewhere, may currently be sleeping on. Hold it without opening it. Some presents are for later mornings than ours. Or, simpler still, maybe nobody answers because nobody else is awake yet. Maybe we're not the stragglers of the cosmos, but its first light. This one sounds like vanity until you look at the clocks. The universe feels ancient. 13 billion years and change, but stars aren't sprinters, they're long-distance animals. The small red stars that make up most of the galaxy's population will burn calmly for trillions of years. Hundreds of times the age of everything so far. So set the universe's whole star-burning life beside a human life, and the strange truth falls out. Right now, all of this, every galaxy, every elder sun, every light in your window, is the first sliver of the first morning, the sky barely grey, the birds not started. Nearly every year the universe will ever live hasn't happened yet, and the households of that long future will mostly stand around the small red stars. They'll be restful places, by our standards. A world close enough to a cool red sun to stay warm gets held by tides until one face turns forever toward the fire, the way our moon holds one face forever toward us. So one side of such a world keeps a permanent noon. The far side keeps a permanent field of stars. And between them, running right around the planet like a seam, lies a ring of endless evening. A band where the sun sits low and amber on the horizon always, where the light is forever the colour of the hour you're in now, and the shadows never move. If minds arise on those worlds, and across the deep future most minds may, they'll arise in countries of permanent dusk. With morning as an abstraction, their astronomers infer, and their children disbelieve. Whole civilizations may keep their libraries and their gardens in the band of evening. However the far future of the valley turns out, a fair share of it will apparently be lived at sunset, in the exact light your room is losing now. As if the universe, given long enough, decides that this hour is the one worth settling in. And in 2016, a group of astronomers weighed exactly this. They asked not when did life become possible, but when, across the universe's whole run, is life most likely to arise, adding up the slow red stars and the long quiet ages ahead. The odds, they found, peak far in the future, so far that, by the plain arithmetic, a mind arising now, this early, around a middleweight star like the Sun, is the unusual case. The anomaly, the too-soon child, and it squares perfectly well with something we met on another night, that the universe's great age of starbirth has already crested. Because stars mostly made isn't at all the same as stars mostly lived. The stars are nearly all born, and they've barely begun to live. The way a nursery full of newborns has done almost none of its living, and is quiet. Not because it's empty, because it's early. If that's the true answer, then the silence of the valley is the silence of a house before the family arrives. And our loneliness has been a simple mistake about the time of day. Nobody answers the young voice calling across the valley because the other houses are still being framed. Their stars steadying, their oceans settling, their first cells still centuries of ages away from their first questions. So every search we run isn't a survey of an empty country. It's the first lamp of the evening, lit early before the neighbours exist, which changes what the lamp is for. Somewhere down the long slope of time, minds not yet possible will look out at an old yellow sun and wonder, the way we wonder, whether anyone was ever here before them, and whatever we've managed to leave, a message, a monument, a habit of gentleness pressed into whatever survives of us, will be their answer. We may be early for the loveliest reason anything is ever early. Someone has to be first, to leave the light on for the rest. And now the thing I've been keeping since the window, because you've got both halves of it in your hands at last. Look at what those two answers have in common. It isn't a mood, and it isn't my preference at bedtime. It's a structure, and it's the most interesting fact on the whole list. 8 explanations failed tonight, and every last one of them failed in the same place. Everyone must abandon radio. Everyone must keep the rule. Everyone must be rare, or afraid, or unrecognizable, or ended. Unanimity is the load-bearing wall of every failed answer of the night, and unanimity is precisely the one thing nothing alive has ever managed, on any scale, for any length of time. The last two don't ask for it. Nobody has to agree to be asleep in the cold, because thermodynamics isn't a policy. It's a bill. Every mind that ever runs the numbers arrives at the same answer privately, without ever meeting the others or hearing of them. And nobody has to agree to be early, because being early isn't a decision at all. It's a date. So these two survive the exact test that killed the other 8, and they survive it without needing one civilization anywhere to have hidden, failed, or died. That isn't the kind answer chosen at bedtime because the hour is late and the room is warm. That's the last two standing, and the reason they're standing is the most rigorous thing in tonight. There's one more beat before we come back up the hill, and it's the one that waits closest to home. Maybe the visit already happened, and we missed it. Or maybe the visitor is still here, sitting quietly, and we haven't found it. That sounds like a story for around a campfire, until you look at how little of our own neighborhood we've actually searched, and how thoroughly deep time erases. Earth destroys its own records. Rain, rust, roots, and the slow burial of the plates recycle the surface so completely that if visitors had landed here 100 million years ago, stayed a century, and tidied up even slightly on leaving, the odds are close to certain that nothing findable would remain. No matter how carefully we dug, 100 million years is a long stay for a secret. And the galaxy has 130 of those to hide things in. The valley doesn't keep footprints. It barely keeps mountains, and the quiet corners of the solar system keep things far better than Earth does. Which is why, in 1960, a radio engineer named Ronald Bracewell suggested the obvious economical move for any curious elder civilization. Don't broadcast across the galaxy forever, which is loud and wasteful. Send small patient probes to promising young systems and let them wait. Park one among the drifting rocks of a system like ours, powered down to a whisper, instructed to sleep until the locals become interesting. A probe the size of a car, dark and still among millions of untracked asteroids, would be entirely invisible to us today. Astronomers have lately begun checking the few special parking spots where such a visitor would most sensibly wait, the gravitational still waters near our own orbit. Those first searches found nothing, and they've examined a handful of rocks out of millions. Nobody knows what's drifting out there tonight. Nobody has ever known. It isn't a spooky thought, held rightly. It's a hospitable one. The guest room of the solar system has never once been fully checked for guests. Then, in the autumn of 2017, something came down the valley road. A telescope on a Hawaiian mountaintop, built to catch near-passing rocks, flagged a fast object leaving the solar system. Within nights, the orbit calculators everywhere reached the same conclusion and sat back in their chairs. It wasn't from here. Its path was open, unbound. A visitor's path. The first object ever confirmed to have come in from the stars. It was given a Hawaiian name, Oumuamua, a scout or messenger arriving from far away, arriving first, and almost nothing about it behaved. It was shaped like nothing we'd ever catalogued. Wildly elongated, a cosmic splinter, or perhaps flat like a pane, tumbling end over end every 8 hours or so. It showed no tail and no halo, though a wanderer of ice should have steamed in the sunlight. And as it departed, it gently accelerated. A small extra push away from the sun that gravity alone couldn't account for. The kind of push a comet gets from venting vapor. Except no vapor could be seen. Every serious explanation offered since asks us to believe in something never observed before. An iceberg of frozen nitrogen shaved off some distant world. An iceberg of frozen hydrogen. A dust structure fluffier than fresh snow. And one famous astronomer, to the visible discomfort of most of the field, kept pointing out that a thin plate pushed by sunlight is also a fair description of a sail. We'll never settle it, and the reason is almost the loveliest part. It's gone. It crossed our sky in weeks. It's out past the orbits of the giants now, receding forever, too fast for anything we currently fly to chase. Though engineers, unable to help themselves, have sketched the pursuit missions anyway, decades of flight, to catch a splinter in the dark. The second interstellar visitor, spotted 2 years later, turned out to be an ordinary comet, steaming happily like comets do, which somehow made the first one stranger by contrast. Almost certainly, Oumuamua was a natural shard. The first specimen of a class of wanderers we'll come to know well, because the galaxy is full of such driftwood, unclaimed and unmanned. But it's a true thing, not a story, that in the year 2017 something crossed our valley at speed, declined to explain itself, and left. And that the honest file on it remains open. The stranger walked past the houses at night, and didn't stop, and nobody got a lamp to the window in time. Travellers exist, now we know, even if all of them, forever, turn out to be made of ice. And one thing is still owed to the seventh answer, the one where the hard rung is behind us, and the valley really is empty. We walked past it quickly on the way down, and it deserves better than a quick walk. Maybe it's just us. Not forever, perhaps, and not in every galaxy, perhaps, but here, now, within any distance that could ever matter. One window, one lamp, and a valley of bonfires burning for nobody. It's the answer people flinch from hardest. And it deserves better than a flinch. Because held still, at the end of the list, it does the strangest thing of all of them. It doesn't shrink you. It enlarges everything you've ever touched. Because if the lamp is the only lamp, then consider what's stored in this one small window. Every lullaby ever hummed in every language exists here, and nowhere else in the universe. All mathematics lives here. Every proof, every furious eraser mark, the whole idea of a name, of calling one star the hunter and another the bear so a child can find them, was invented behind this one pane of glass and exists in no other place among all those hundreds of billions of fires. Mercy exists here. Jokes exist here. Tea, and the entire notion of a held cup on a cold night, exists here. So, if the valley is empty, then this window isn't a small lit thing in a great dark. It's the place where the universe keeps its diary. The one address where atoms arrange themselves carefully enough to look back up at the fires they came from and start writing everything down. Rarity has never made anything less. In every attic and every museum and every heart it has only ever made things more. One of those two record-bearing ships gave this answer its portrait. In 1990, as it crossed beyond the orbit of Neptune outbound, its cameras were turned around one last time to photograph the family of worlds it was leaving. And in the frame that included Earth, our whole planet came out as a single pale point, smaller than 1 pixel, caught by pure luck inside a stray shaft of scattered sunlight, like a fleck of dust drifting through the light from a gap in the curtains. The astronomer who'd campaigned for that picture, Carl Sagan, spent the rest of his life saying plainly what it showed. Every person who has ever lived, every language, every wedding, every worry, every lullaby, all of it happened on that one lit grain. People sometimes hear that as a lesson in smallness. But lying here, at the end of this particular night, you can hear the truer version in the largest family photograph ever taken of the valley. The only thing in the frame that has ever asked a question is the smallest thing in it. The dot doesn't diminish the diary. The dot is what a diary looks like from across the valley. Still faithfully lit, and it would mean the night has a job in it. That the job is already being done, and that you're already part of the crew doing it. Because if there's one lamp, then the whole task of the universe's inner life comes down to tending it. And tending it turns out to look exactly like the things people already do without being asked. Teaching a child the moon's name. Writing things down for people not born yet. Keeping each other warm through winters. Repairing what tears. Civilization, under this answer, is simply a very long night watch over a single lamp, handed carefully from one generation to the next for 10,000 years, each shift doing its stint and passing the light along. And tonight, for a few decades, part of that watch is yours. But here's how a night watch actually works, and how it has always worked. In shifts, which means the watch is kept precisely by most of the watchers sleeping. Resting isn't leaving your post. Resting is how the post is kept. The lamp doesn't need you exhausted. It needs you back at breakfast. So walk the whole list once more, one slow step each, the way you check a house before bed. Maybe we've barely looked, and the silence is a bathtub drawn from an ocean. Maybe the letter is waiting at a post office we haven't found. Maybe the paths are bent away from the cottage on purpose. Maybe the residents are nothing like us, slow as geology, or sealed under ice. Maybe living worlds are rare, and everything ordinary in this room is treasure. Maybe the forest is shy. Maybe the hard rung is behind us, and the empty sky is the view from a summit. Maybe it's ahead, and the sky is a warning built from a sample of nobody. Maybe the elders are asleep until the cold makes thinking cheap, and maybe we're simply early, and someone has to be first. 10 answers. They can't all be true. 8 of them have a hole in them you can now find yourself. And the 2 without one are the 2 that ask nothing of anybody. Nobody on earth knows which is right. But what every single one of them has in common, from the coldest to the kindest, is that not one of them asks anything of you before morning. And notice what the question itself was all along, underneath its physics and its arithmetic. Where is everybody isn't really an astronomer's question. It's the question a mind asks in the dark when it wants to know it isn't alone in the house. The oldest bedtime question there is, older than beds. Our whole species has been standing at the window in its pajamas for 1 century, which in valley time is 1 blink, calling down the dark hallway of the galaxy. Is anyone home? Listening hard, hearing the house settle and wondering what the settling means. That's all the Fermi paradox has ever been. The childhood of a civilization, listening at the top of the stairs. And the answer, every child eventually learns, is the one the valley has been teaching us gently for 75 years. Quiet isn't the same as empty. Morning explains what midnight can't, and the house has held you all night either way. One more small, true thing, and then the letting go. Somewhere in tonight's list, or just past its edge, in some shape nobody has imagined yet, one answer is simply true. Right now, tonight, the valley actually is one particular way. It was already that way when the four physicists sat down to lunch. It was that way over every roof you've ever slept under. It'll be that way at breakfast. And whichever answer it is, it has been true through every peaceful night this world has ever had. The truth about the Great Silence has been overhead your entire life. And your entire life, it has let you sleep. Whatever the sky is keeping, it keeps it gently. That's the one finding of tonight you can verify from bed, and you're verifying it right now. So let the rest go. Let the lunch table and the blackboard drawers and the fan-fold paper drift off like breath fading from cold glass. Let the forest keep its story. Let the wardens keep their rounds. Let the sleepers keep their long appointment with the cold. None of them need you to hold them, and none of them will be an atom different at breakfast. If your shoulders are still up around the question somewhere, set them down with it. You were never asked to solve the valley. You were only ever asked to live in one small, warm corner of it, which you're doing right now correctly. Do it the way a house is put to bed, one lamp at a time. The canal maps of Mars, lovely and wrong, off. The waterhole still murmuring in the quiet band, leave it murmuring, off. The kitchen table in Ohio with its red pen and the golf course growing grass over the listening ground, off. The dipping star, dust after all, off. The two record ships, out past everything, carrying the sound of rain. Leave those on. They're doing no harm. They like the dark. The forest. Just trees now. And deer in them. Off. The wardens on their soft rounds, the sleepers in their long cold bedroom, the unborn households of the evening worlds. Off, 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 off. Gently, none of them mind. Until the only light left in the whole valley of tonight is the one small lamp of your own attention, and you're free to carry it upstairs and set it down and let it go out on its own, which it's already doing, exactly as it should, and sometime tomorrow evening you'll pass the window again at the hour the glass goes black. The valley will be there, and it'll read differently than it did before tonight. Not an emptiness. A neighborhood at dusk, holding every good possibility at once. Shy neighbors at the tree line. Elders deep in their long sleep. Houses still being framed for families not yet born. A stranger's footprints on the road. Or one single lamp, yours, precious beyond every calculation, keeping its small, faithful light in the biggest night there is. Every one of those is a good sky to live under. You can turn out the lamp gladly under any of them. The watch is kept. If you're still awake, and you'd like one more journey, there'll be another one waiting on the screen to carry you onward. Otherwise, just stay here in the quiet, under a sky that has kept all of its secrets, and still lets everyone sleep. The stars will keep spinning while you sleep. Good night.